Hello everyone. Today let's try to understand the object relational mapping part in the Spring. So, how we exactly work with the operational mapping in Spring. So, let's first try to understand what exactly is object relational mapping. So, before that, let's see the learning agenda for today. That is, integrating the Hibernate with the Spring framework. So the first part is configuring the session factory in Spring, implementing DAOs using this Hibernate template class, implementing the Spring based DAOs without using callback objects, implementing the programmatic transaction management and how it's done, implementing the declarative transaction management and the ways we are using, ways in which it can be done, and developing the Spring application with Hibernate. Let's see all these. Before that, let's understand the introduction with the object relational mapping. First, let's see the introduction to object relational mapping. So, if we consider the real world applications, when we develop these real world applications using the Spring framework, what we need to do often, we need to store and retrieve the data. That is very important. For that matter, for any of the application, storing and retrieving the data is very important. So it needs to be stored and retrieved often. So that is done to and from the relational database. So this is done in the form of objects. So these objects usually are non-scalar values. That is, we cannot directly store the objects and retrieve the objects from the relational database. So, because these scalar values can be directly stored in the relational database. So, what we do here is the object relational mapping, or in other words ORM, or OR/R mapping technique is a technique of persisting and storing the objects into a relational database. So this ORM technique, what it does, it translates the objects into database and makes it the compatible forms which can be stored in the database. However, it needs to be stored, the type of the data, how, in what format, compatible format it needs to be stored. In such a format, this ORM technique translate that particular object so that we can later retrieve these objects or the data stored easily while preserving the properties of the objects and their relationships. When we develop the data access application using the Spring frameworks, so first we need to see whether it has a support for the ORM. So our Spring framework that we are learning here, it supports this ORM in the form of reusable Java beans. So as we already know, the Java beans are nothing but the POJO. It can be used as a library irrespective of the data access technology used with the framework. So in the Spring framework, there is a ease of testing, also handling the exceptions, handling the data access exceptions, and general resource management. Also, while implementing the ORM, we also have a support for integrated transaction management. So, since we are having all these supportive technologies, this ORM mapping with Spring it is coming with ease for the developers. So now let's learn about working with the ORM tools in Spring. So before that, let's know some things like we can integrate the Spring framework with various ORM supported frameworks like the Hibernate or JDO or Oracle TopLink or IBATIS SQL Maps and JPA. So how it helps? Now we are learning about integrating Hibernate with the Spring framework. Before that, let's learn about what happens and how we are integrating the Spring framework with various object relational mapping techniques. So, if we consider it could be a Hibernate or Oracle Top Link or IBATIS SQL Maps or JPA, how the integration helps? The integration helps in terms of the resource management, DAO implementation support and transaction strategies. The Spring framework also provides, as we all know, the inversion of control technique which helps us to be very convenient with the features for Hibernate integration, which addresses many typical Hibernate integration issues. These support packages for the ORM and which helps in Spring generic transactions and DAO hierarchies. So now let's see how the integration of Hibernate with the Spring framework happens. As we all know, Hibernate is a very powerful and open source ORM tool. One of the most important open source ORM tool is the Hibernate. It lies between the application layer and the database layer. It helps in easy data access and manipulation. Also, it helps in storage and the retrieval of data to and from any relational database. So, it also does all these works in a platform independent manner, and we need not write the code for managing the connection here. So, all the statements, prepared statements, result sets, everything will be done by itself. All the details of accessing that particular data source, how it is done by itself is configuring in the XML files. So, when our application accesses the particular database with the help of the Hibernate framework, it depends upon the Hibernate application programming interface. The application depends on that particular Hibernate API elements, like for the example, the configuration, session factory, sessions handling, everything will be done by the Hibernate API elements. So usually these APIs are scattered across the code throughout the application. What we need to do, we need to manually maintain and manage these objects. So the integration of this Hibernate file with the Spring resolves all these problems. So how it is resolved? It is done by using the configuration of the session factory in Spring, implementation of DAOs using Hibernate template class and without callbacks, and programmatic transaction management implementation and declarative transaction management implementation. So let's see all these things one by one. The first and foremost and very important thing is configuring the session factory in Spring. So the Spring framework, it allows resources like the JDBC data source or the Hibernate session factory as beans in the Spring container. So declaring these resources as beans, it helps in avoiding the hard coding. Instead of hard coding the resource lookups for the application objects, we can define all these resources. Also, the session interface in the Hibernate API provides methods to save, find and delete the objects in the relational databases. The Hibernate session is created first by creating the session factory. So, for session creation, what we need to do? We need to implement the abstract session factory bean subclass. So, there are two things in that. That is local session factory bean, annotation session factory bean. So what exactly is local session factory bean? This class needs to be configured with the mapping file locations from the application's point of view. So here this annotation session factory bean is a subclass of the local session factory bean class. So for integration of the Hibernate with the Spring framework, we can use this as it supports higher versions of JDK and annotation metadata as well for all the mapping related stuffs. So let's see a code snippet which shows the configuration of Hibernate session factory, which is very important. So how it is being done? First, there is a bean ID with the name my session factory. This is a declaration, and it also sets a data source, mapping resources and Hibernate properties. So the mapping resource property, what it is doing here, it is a set, it is having a set of values which can be converted into a Spring resource. So it can be accessed anywhere in the Spring application. In our case, we are also having here the student.hbm.xml file declaration here. So since that HBM file is present, we also need the dialect, SQL dialect to be used. This Hibernate dialect property is set to MySQL dialect, which allows us to use MySQL database. Next, implementing DAOs using Hibernate template class. So in our Spring application, an approach of persisting objects into the relational database is using of the ORM template classes. The Spring API basically it consists of the Hibernate template class. What that class does, it provides template methods for different types of Hibernate operations like managing the Hibernate session, minimizing the effort involved in manually managing the sessions. So the methods, there are various methods available in this Hibernate template class. These methods are present to ensure the proper functioning of the Hibernate sessions. For example, like opening the transaction, closing the transaction, and many such operations. So that is managing the transaction. There is no need for explicitly writing the code for transaction management. So the Hibernate template class has the methods that takes instances of the Hibernate callback interface. So now let's see in this below code snippet. Here we have created a class named Hibernate template rep. In this class, this Hibernate template class is instantiated. How it is being done? By first invoking or passing the instance for this session factory instance. So within the constructor. Next we are having the execute method which is invoked, and an implementation of this Hibernate callback is passed. All these things are done to interact with the database. So an instance of this session interface is passed in the do Hibernate. Here we are having something called do Hibernate method. In this do Hibernate method, this will never be null, because always the instance of the session will be passed to it. So the value returned from this particular do in Hibernate is propagated to the caller class as a result of this execute method. Next we are having implementing the Spring based DAOs without callbacks. As we already know, the Hibernate template class of Spring API is one way of implementing the DAO. Apart from that, there is another way, that is without callbacks. The Spring API, what it does is it provides this Hibernate DAO support class. This is very important here, Hibernate DAO support class, which implements the data access code without wrapping the Hibernate access code in a callback. This is another way to implement the DAO. The Hibernate DAO support class supports and participates in the Hibernate Spring's generic data access exception hierarchy. So now we are learning about implementing the Spring based DAO without callbacks. What exactly is happening in this code snippet? The student interface is defined with a declaration of, there are two methods here. One is save students and next is the get students. So what is save students doing here? Both these methods are declared implemented within the Hibernate student DAO class. The implementation of these two methods are simple and it is having a very few lines of code, as we can see here. We are having a method here, save or update. Here it is to find the students from the student table. This is because of the usage of these two methods. There are very few lines of codes here. That is, save or update is a method and find is another method. Get Hibernate template is also another method, which also makes the code very simple. So without callbacks, we can implement in this way. Hope it is very easier to understand. If we remember these three methods, that is save or update, find and get Hibernate template. These three methods which are present in the Hibernate DAO support class helps us to implement the Spring based DAO without callbacks. Next is implementation of the DAOs based on Hibernate 3 API. It's a plain API. So apart from using the Hibernate template and Hibernate DAO support class, we also have the DAO implementation based on Hibernate 3 API. This API can be used to implement DAOs when integrating the Spring with the Hibernate frameworks. The Hibernate framework can also itself manage a session per transaction using the feature of contextual session. It is called contextual session. This session management is a kind which is similar to the Spring synchronization of one Hibernate session per transaction. Contextual session means one Hibernate session per transaction. That is the meaning in the session management. So how it is done? Let's see this public interface student DAO. So we are having this DAO implementation which implements the student DAO. In this code snippet, the DAO follows the dependency injection pattern, which is well supported by the Spring IOC container. So how it is being done and what are all the advantages of it? The advantages are there is no need to import any Spring class, and it is also simple for the Hibernate developers. Somebody is a Hibernate developer, the usage of this is very simple. So what is happening here is a local factory session bean supporting session factory.get current session. If we see this line, session factory.get current session method, it is the method that is also present in the Hibernate API. This method returns the current Spring managed transaction session even without the use of Hibernate transaction manager powerful class. So that we will discuss in the next sections. So this part is very important here, session factory.get current session. Next is implementing the pragmatic transaction management implementation. As we already know, transaction management is a very important aspect for object relational mapping as well as in the Spring framework. This programmatic transaction management, what we need to do, we need to write code in our beans for the transaction management. For implementing this in Spring, we need to use, there is one thing called platform transaction manager, which we can see here. Platform transaction manager class we need in our bean class, which is used to create the instance of the transaction template class. The transaction template class that we can see here is used in the same way to manage the Hibernate transaction. However, how we used the Hibernate template class, the same way we use here. So here in this code snippet, the programmatic transaction management, how it is. So we are learning about the programmatic transaction management implementation. Here if we see the code, in this code snippet, the programmatic transaction management is implemented to get the list of students from the DB. So we have used the instance of the platform transaction manager here and the transaction template class in the code. It provides methods to perform this transaction management programmatically. So there is no, we are having the execute method here, that is very, very important. Next comes the declarative transaction management implementation. How this is done? We, apart from doing the Spring application programmatically, that is the transaction programmatically, we can also manage the transaction declaratively. What is declarative transaction management? It refers to the process wherein we do not need to write the transaction code as we did in the previous example. In our bean class, we can make a declarative transaction management by configuring the properties within the application context.xml. That is very, very important here. Configuring the bean class into the application context.xml file. Implementing this declarative transaction management in Spring has the advantage like it is very flexible approach. There is no need to change the application code all the time. If there is any change in the requirement or anything, we need not go into the application code and make all the changes all the time. While using the declarative transaction, we can just do in the application context.xml. Also, what all needs to be done is to modify the application context as per the requirements, our requirements. So there are three ways in which this can be implemented: with AOP interceptors, with a schema with annotation, with a schema without annotation. Let's see how it is being done with AOP interceptors. That is, we are discussing here how the declarative transaction management is done with AOP interceptors. So it helps us usage of the Spring AOP infrastructure part. So what it is, the Spring AOP creates a Java development kit. Java development kit proxy. It is called a proxy. Why we call it as a proxy? Let's see. To intercept the method calls, a proxy call is done. So there is also another term called load time weaving approach here. What is exactly being done is, this load time weaving approach is used to weave the aspect at the load time. We have already seen the aspects in our previous slides while learning the AOP. So at the load time, it is used to weave that particular accept and eliminates the need of the proxies. So how it is being done? Let's see here. Here we need to mainly understand the two important things, that is transaction interceptor and hibernate interceptor usage. So both are the bean names that are created and it is taken from the class org.springframework.transaction.interceptor.transaction interceptor, and hibernate interceptor is from the org.springframework.orm.hibernate3.hibernate interceptor. So both are the usage of this. In this code snippet, what we can see is both the beans are declared and the beans are used to set the transaction properties, and hibernate interceptor, why it is used to manage the hibernate transactions. So with this small change, we can manage and implement the transactions. So these two are very, very important. The changes with the transaction interceptor and the hibernate interceptor. Transaction interceptor for the transaction properties, while the hibernate interceptor to manage the hibernate transactions. Next is declarative transaction management with annotations. So what exactly we are doing with the annotations here? Let's see here. Annotations for that particular schema based declarative transaction management are not inherited. It is not inherited from any class. We declare these annotations at the class level itself with the help of @transaction. We are learning about declarative transaction management with annotation. First, we need to know that these annotations are not inherited. We declare these annotations at the class level with the help of @transactional. This term we need to know very much. @transactional annotation. While using these annotations, we can declare the transaction manager and add TX colon annotation driven here to the application context. But if we name the transaction manager itself as transaction manager, we need not declare this property @transactional annotation here. Directly we can work on it. But if we declare the transaction manager, then that will be the default value of that particular attribute. Also, the point cuts that we use must be declared in the service class itself. So, the transaction management here is performed with the schema based configuration with the use of annotation, that is by using @tx colon annotation hyphen driven closing bracket. Where it is done after this part we are seeing here, the transaction manager property. After this we will implement this tx colon annotation driven tag while performing the schema based configuration with the use of annotations. We are also having another approach without using annotation. Let's see that. Now let's learn about the declarative transaction management without using annotations. As we saw with annotations, we are having mainly the usage of the transaction manager. Once the bean declaration is done, we are having TX colon annotation driven. That is not present in without annotation implementation. What we have after declaration of the bean transaction manager and session factory, we will have the AOP aspect oriented programming config and point cut methods which execute the expressions. So we directly go to it rather than declaring TX colon annotation driven. That is one of the important part where whatever this code snippet is explaining. Now let's learn about the various steps in developing the Spring application with Hibernate. Rather than we will go in detail in the next slides, but let's now understand the important steps in developing Spring application with Hibernate. So in order to develop an application with the integration of the Spring and Hibernate frameworks, the main thing that we need to know is we are having the application to be MVC based application. That is, we can segregate that as model, view and controller components. The application being developed in the Spring Hibernate app, and it is a web application. Apart from this MVC components part, we also need the configuration files. That is also very, very important to be noted. Also, if we are developing an employee application, we need some employee name, department name and storing the value to the database. So DB part is also equally important. So apart from that, what all we need to know is developing the model components. That is the first part. That is, if we think that we need an employee application, so we need an employee bean. That is employee name, employee department, employee ID, getters and setters or the POJOs for this. That is said to be the model, and name it as the employee bean.java, which is having the getters and setters. Next comes the view development. The view component development is an MVC based application wherein the inputs are taken from the user or the end client, application client. So we need to know that is employee form view and whether it is successful or not, successful display, whether all the employee details are got or the error message. So success view, failure view and the employee form view are important here in the view part. Next comes the controller part. So this view part, it will have the success JSP, failure JSP, or the error JSP. So JSP and employee form.jsp. So totally 3 things comes here in the view part. Employee form.jsp, success JSP, failure JSP. Model will have the employee form.java, which contains the getters and setters for the employee. Controller is basically, it is the application controller, that is employee controller, which controls the sequence of execution of the entire application. So first, if we decide on the view component, the controller components directly will depend on this. So how that will be an employee controller.java, which extends the simple form controller, wherein we throw all the exceptions, we do all the saving of the data, insertion of the data, saving of the data, model and views, whether it goes to the success page or the failure page, everything is dependent upon the controller. Also, we are having a DAO class.java, employee DAO.java, where we declare all our session factory transaction management aspect. Along with that, the validation of the employee name, that is, if there is any validation, employee name should not be null, it should not have spaces. Department name should not be null, it should not have spaces. Such things also will come under the controller component. Then configuration file will be employee.html, hbm.xml, and application context.xml, and web.xml. As we know, in all the applications it will be there. These comes under configuration. Deploying the application. How we deploy our application? First, next comes the deployment of the application. In order to deploy or the execution of the application, we need to know which application server it is running on. So whether it is a Glassfish application server, whether we need to create a var file for that. So all these things we need to know. So we need to directly go to the Glassfish. We need to see whether the Glassfish server is up and running. Go to the localhost part of it, or if it is running, depending upon the environment. If it is running on our local machine, we will go to the localhost :4848 or whatever the port number is. There we need to go to the web application and see whether that particular var file or the web application file has been deployed. Otherwise, we need to browse and deploy that application, that whether to ensure that it is deployed properly. Lastly is the running of the application. Our Spring Hibernate app, first we need to go to our localhost :8080. There we need to give the dispatcher path, that is the front controller part, that is front page, and since we have specified everything in the controller, it directly runs. If it is successful, it will display the success.jsp that we created in the view components part. That is very, very important.